Hello, friends. This is a podcast review, what we were studying before our 2.5-week vacation, just to get us back in the groove. And we were studying quadratics. And remember, we said a quadratic is any equation or function where the highest exponent is 2. And that when we graph a quadratic, we get a parabola, which is a U shape. And this one opens up, and I would know that it opens up if the a term were positive. And if it opens up, it would have a low point or minimum. And that minimum would be at the vertex right here. And through the vertex, I would have a vertical line called the axis of symmetry. And all these terms should be familiar to you. If this a term were negative, I would have a parabola that opens down, but I would, instead of having a minimum, I would have a maximum right here. And that maximum would still have an axis of symmetry right through the middle. And that maximum would be called the vertex, this point right here. Remember, we called this form the standard form. And in the standard form, I knew that I could find the vertex by finding the x-coordinate, which would be negative b over 2a. And so the a is whatever number is in front of the x squared term, the b is whatever number is in front of the x term, and the c is whatever number is the constant with no x by it. So once I knew the x term, which I could get right here, I could plug this value of x into the equation and get the y term. In addition, this c tells me the y-intercept for the parabola. So all this should be review, and then we follow that up with two different forms of quadratic equations. We had vertex form, which was vertex form because the h and the k were the actual coordinates of the vertex. A served the same purpose that it did in the regular form. Positive opens up, negative opens down. And then we had the intercept form, which was handy because that told me that the P and the Q were my two x-intercepts. And if I knew that, I could find the axis of symmetry and the x-coordinate of the vertex by finding the average of the P and the Q value. So all those terms and all those forms should be familiar to you. So I'm just refreshing your memory. Now the last thing we did was to start factoring. And remember, I said that this was not such a bad way to start because in this section 4.3, the a term was always 1. And so what we were doing was taking equations that were in this standard quadratic form and basically rewriting them in the vertex form that we'd already done. So if I started with an equation like this, I would know that I was going to take this trinomial and break it into two binomials. Further, I would know that the first term in each of these binomials had to be x because of my foiling. I knew the first two terms, this and this, have to multiply the x squared. So then I'm done. So then what I need to do is find two numbers, and we're going to call those P and Q, that I can plug in here, and I need the P and the Q to multiply. Actually, I'm going to change those to M and M just to be consistent with these notes. All right, and I need the M and the N to multiply together to give me the number -8. And when I add them together, I need them to give me the +7. So we would find all the factor pairs, and remember we said everything that multiplies together to give me -8, -1, +8, 1 and -8, -2 and +4, +2 and -4. So I have 4 possibilities. These are the only things an M and N can be. So now I'm just looking for the one that gives me a +7 when I add them together, and it's this one. So from this, we were able to factor. Remember, this is something we just had to practice over and over again. So where are we going with this? We are now going to start factoring quadratics where there's an a term other than 1. So I want you to look at this example here, and I want you to pick which of these factorizations you think is correct. All right, we'll see you Wednesday morning.